Let us talk about vector fields. Now, you know what a vector is from previous video and so on, right? But the vector field now, it's really a function that assigns a vector to every point in space. It could be, for example, the wind blowing from left to right. You want to represent the wind as a vector. You have a direction and you have magnitude, right? Where the length of the line representing the vector, it shows the magnitude, and the arrow on it is the direction. So could be, for example, vector AB is the wind blowing, but you could just draw one vector. You want to draw, if it is a field instead of a single vector, you want to draw many vectors, right? The fact is, if you hold up, for example, a feather, you see the effect of the wind blowing on it. And no matter whether you move it up or down, you won't have a point where there's no wind and then there's wind. You move it 1 centimeter down and you find that that spot doesn't have any wind. If you move it another centimeter down, then you see wind again. No. So on a diagram, this is what it looks like. But the fact is, you could use an infinitely large number of vectors to make this field, right? It could be gravity, the force of gravity acting downwards, right? You use lines pointing down with arrows on them like this. As well as you have other things that create a vector field. It could be a magnetic field consisting of each flux line. It could be an electric field. It could be fluid flowing, right? And so on and so forth. Now, it's like, say, for example, you have a pane of grass. So just one piece of grass you have growing in a pot. But when you have a field, like a football field or some type of field in a community center that can be used for football or running or other recreational activities, you have many of this type of grass growing all over it, right? So you call it a field, large number of individual grass growing on it, so you call that a field. So it's somewhat a similar idea. You're talking about a vector field, you show lines of many vectors, right? Why is this thing jumping like this? All right. Now, let's look at a few examples of a vector field. I plotted some vector field. Specifically, I asked ChatGPT to plot some vector field. Okay. So this is vector field 0y. Right? Let me open it again. The vector field 0y. You notice at 0, you have no lines. Then you move upwards, you see lines pointing up. Here. And they get longer and longer. If you move downwards, you see lines pointing down as they get longer and longer. Alright? Now, it's somewhat like this. If you have your vector field, say, in this case, what is it again? 0y. 0y. Now, by the way, a vector field, you have a general way of writing it. The function representing a vector field, right? Let's do this. Say this is a function of x and y is equal to, you could say part of the function is p x and y I plus q of x and y j, where the y-axis would be horizontal, right? And the j-axis vertical. So in this case, seem to be having some issues with this thing. It's doing all sort of thing that I didn't ask it to do. Let me just do a little thing here to see if I can correct the issue. As it magnified it and I didn't do that. I wasn't the one who did that. Alright. So such is the issue with technology. Right? Sometimes it seems to have its own mind. But anyway, you have I pointing in the x direction and j pointing in the y direction, right? Pi plus qj. Now, in this case, it's a vector, right? With the I and j direction. Remember, when you use the angle bracket like this, the 0y, it's really saying 0i plus yj. Alright? Now, remember that you have different ways you can write vectors. Now, one of the ways we are going to be writing vectors when we do line integrals is in the form p of x, y. Remember, p and q are functions, right? P of x and y dx plus q of x and y dy, where dx is a change in the x direction, similar to I. So this would be dx going this way. Dy is a change in the y direction, change in j, y direction. So dy would be up like that. Alright? P of xy. It could be x plus y, or it could be x squared minus y cubed, whatever it is. It's a function of xy. You call p in the direction of x plus, and then q of xy, it could very well be x squared plus y, it could be 3x minus y squared, or whatever else. This is a function q of xy dy. In this case, the 0y shows that x is 0 and y is 0. And the y alone, right here, shows that you have y and x is 0, so you don't bother to show it, right? Alright. Well, you have y alone. If you say y plus x and x is 0, it's just y. Alright? But in this case, what this vector is showing is 0 dx plus y dy. Alright? So the way that we'll be writing vectors, the most common way is this. A function of xy dx plus a function of xy dy. Alright, now this vector field 0y, like you have x and y axis. I have 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here, to plot this vector field, when x equals 0 and y equals 0, then the vector is 0 in the x direction, 0 in the y direction. Alright? So that's why you didn't see any lines in this region at 0. But they have their 0 going up. They didn't bother to put lines on the x-axis because it wouldn't make any difference. All of them are 0. But anyway, I forgot for a while that x is really 0. So didn't bother to label it. -1, -2, -3. X is always 0, so you don't need that. Now, here, what happened at this point? Well, at this point, x is 0 and y is 1. So if you plot this point, you go 0 in the x direction and 1 in the y direction. So here this is 1 unit long. What about 3? What happens at 3? Well, at 3, x is 0 and y is 3. So this must be 1, 2, 3 units long. If you had 6 up here, 0y means 0, 6. So it's 0 in the x direction and 6 in the y direction. So this would have to be 1, 2, 3, 4, 5, 6. Right? At this point, same thing happens. So as you go up, the vectors get longer and longer. When you talk about here now, 0, -1. You're not supposed to move to the left or right because x is 0, but you go down 1. Alright? If you're at 4, 0y would mean that you must go 0 to the left or right. You don't move left or right. -4 down, 1, 2, 3, 4, and so on. And it doesn't make a difference where you put the x-axis, where you put the vector along the x-axis, the same thing would happen. So as you go down, the vectors get longer. As you go up, the vectors also get longer. So that's what you're seeing in this diagram. As you go up, the vector just get longer. As you go down, the vectors get longer. Alright? Alright, so we'll plot another vector field in the next video.